Okay, so today we are about to treat the topic logarithms. And as you know, we have all heard about logarithms, and we are wondering what is the term logarithm. So when you say logarithm, assuming you have a log of any number, let's say b, to a base of a. So this is how it is written: log of any number b to a base of a. So this simply means the number of times the base, that is a, should be raised, or the number of powers a should be raised to get b, is what is written in this one. Okay, so assuming the number of times is c, so we can say that log ab should be equal to what? C. That means the number of times a should be raised to an exponent to get b is what? C. That means a exponent c should be what? Should be b according to the definition. Are you okay? So logarithm of a number b to the base a is the number of powers, or the number of exponents a should be raised in order to get what? B. So this is a simple expression for it. Okay, so this log of a to the base b, sorry, log b to the base a. So the a here shouldn't be equal to 1, because you don't have a log to a base of 1. When you have something like that, it means your answer is error. And this a shouldn't be negative number, because you don't have log to a base of a negative number. So this a should be what? It shouldn't be negative. So it shouldn't be equal to negative a. Are you okay? So, and when you have a log, let's say log b, and the base is not written, it means that the base here is what? Is 10, but we don't write. So if you do your calculations and you have base 10 here, you can decide not to write. It is acceptable. So let's take quick example and look at how it is done. So let's take log 216. So how will we solve log 216? So it's a simple matter. According to the definition, we said log ab should be equal to what? C. That means the number of times a should be raised to an exponent to get what? B. So here too, the number of exponents 2 should be raised in order to get what? 16. So that 16, that number of exponents we don't know. So let's represent it by a variable x. So we say this one should be equal to what? A variable, that is x. Are you okay? So that is x. So according to the definition, we say 2 to an exponent of, x should give us what? 16. Are you okay? And we know that from indices 2 exponent x, 16 can be written in the base of 2 as what? 2 exponent what? 3. 2 exponent 4, which gives the same as 16. So according to indices, the base are the same, so this one cancels this. Then we have our x to be what? 4. So I have a simple illustrative example for you to solve. So solve this one for me. I'm waiting for you. Log 232. So solve this one without using calculator. Okay, so we are looking at the laws of logarithms. So we say the laws of logarithms, it is basically 4, but in some book you may find more than that, but basically it is 4. So let's look at how it works for the laws. So let's look at law 1. So the first law of logarithm says, if you have a log, like a log a x to the base a plus log a to the base, let's say y. You see here, the base should be equal. Like here is a, here is a. Here shouldn't be maybe a and here is b. Nah, it won't work. It's supposed to be what? like basis. Are you okay? So then if you have something like this, according to first law, it means it says you can write the log a, then you multiply what the numbers, that is what x and what y. So you are having what log of what x multiplying y to the base of what a. Are you okay? So that's the first law. So let's take an illustrative example and let's look at how it works. So example, we have log, I told you the base should be the same, so let's say 2 then 3 plus log 4 to the base of what 2. So here the bases are the same, then we can apply the first law. So let's look at how it works. So here we bring our log 2 out. Take note, if the bases are not the same, which one will you bring out? You won't know, so it is necessary to check whether the bases are the same in order to apply this law. So let's look. According to the law, we multiply x and y. So here we are multiplying what 3 and 4. That's 3 multiplying 4. Then we are going to have what log 2 what 12. So if you like, you can simplify this further by what I did. Like the number of times, the number of powers 2 should be raised to get 12. So that is what 2 exponent x giving us what 12. If you like, you can equate this one to x. Are you okay? So this one, you see, you don't have any possible like things, so you can leave your answer in this form. So you can leave your answer in this form as the final answer of the day. So the second law of logarithms is, it says when you have a log x to the base a minus log y to the base a, the law says you must do this log a out, then you divide our x by what? By y. That's the second law of logarithm. So let's look at the third law of logarithm. This one, let me give you an example for you to try. This one is a fast thing. So log 3 5 minus log 3 2. So solve this one, I'll be waiting for you. So let's continue with the third law. So the third law says if you have, let's say, log s to the base a and a x to an exponent of n again, then the law says you have to bring the n here, that's n, then it's left with us log a x. So you have log x exponent n to the base of x, to the base of a. You bring the n with as first here, then you bring your log s to the base of what a. So that's what the third law of logarithm. So let's look at the fourth law. So the fourth law says we have log s to the base a exponent to the base a like this. It can be written as log x is to the base of what b dividing log a to the base of what b, where b is a constant number, so you can change the base according to this law. So as time goes on, you know how to apply this law.